So hello guys, in this video we are talking about Databricks and Spark code. So first question is, what is Spark architecture, and explain the driver, executor and cluster manager. Spark follows the master worker architecture where the driver plan the job, cluster manager allocate resources, and executor run the actual task. Driver means it is the brain of the Spark application. Run your main or notebook code. Create Spark session and Spark context. Convert your code into DAG, means direct acidic graph. Split DAG into stages and tasks. Track the process for each task. There is only one driver per Spark application. Executor. Worker processes the run on the cluster node. Executor runs the task assigned by driver. Data stored in memory disk. Report result and status back to the driver. Each Spark application get its own set of executors. It is isolated. If executor crash, the driver reschedule those tasks. Cluster manager responsible for allocating resources, CPU and RAM to Spark apps. Spark support YARN, means for Hadoop ecosystem, Kubernetes for containerized environment, Databricks managed for full abstracted what you use at FV, like in our project. Then standalone Spark building manager. Data flow diagram is your PySpark job, then Spark session. It is created by driver, then cluster manager request to the resources, then worker nodes, means executors. Task run on partitions, like result return to the driver. In Databricks, the driver is cluster manager node, master node. When I submit ingestion job at FV, the driver passes my transformation plan, and Databricks cluster manager allocated executor node, and each executor process the partition on the of the API data. What is difference between RDD, data frame, and dataset? RDD is a low level, type safe but slow API. Data frame is high level, schema aware, catalyst optimizer API. Dataset combine both type safe plus optimizer, but only in Scala and Java. Why PySpark use data frame, not dataset? Python has no compliance time type system. Dataset only available in Python. Data frame is a dataset row internally in Spark. In Python job, likely in my project, I always use data frame. They basically in RDD introduced in Spark.1, type safety is compile time, no schema, no optimization, language for all, performance lower, API level low level, rarely use. Data frame is built from 1.3 Spark, type safety, runtime only, catalyst plus tungsten optimization, schema is yes, language all, performance fast, API level high level. Dataset 1.6 compile time, catalyst plus tungsten, schema yes, language Scala and Java only, fast and high level. Then explain catalyst optimizer. Catalyst optimizer means Catalyst is a Spark query optimization engine that automatically write and optimize your query plan before execution, similar to how database query plan work. First, it will go for first phase is analysis, resolve the column name and checks if the database is not exist. Then logical plan, apply the rule-based optimization like predictive pushdown, column pruning. Predictive pushdown means remove filters as early as possible. Column pruning means drop unusual column before reading. Partition pruning means keep irrelevant partitions. Constant flooding means evacuate 1 plus 1 is equal to 2 at runtime. In planning, physical planning, convert logical plan into one or more physical plan. Choose based using cost based optimizer, and should this join be broadcast join or short merge join, which partition order is best, like that. Then code generation means tungsten, generate optimizer JVM bytecode for physical plan, eliminate virtual function call, directly CPU execution. When I optimize Spark pipeline at FV, I achieve 50% reduction in processing time. Catalyst predicted pushdown into iceberg metadata was one of the biggest contributor. It avoid full table scan. Then what is tungsten and how does it help performance? So tungsten so tungsten is the Spark CPU and memory optimization engine that bypasses the JVM garbage collector, use compact binary data format and generate faster bytecode, making Spark dynamically faster at the hardware level. Detailed explanation. Tungsten solve the JVM bottleneck in Spark. Three main optimization: off-heap memory management, cache awareness, whole stage code generation, and vector execution. At FV, enable arrow based. Sorry, again. In FV, in my project, enable arrow based execution was one of the my configuration tuning step. It reduced JVM to Python data transfer overhead significantly when processing high volume of API workload. Explain wide or narrow transformation. Wide means each partition produces output from exact means like output is dependent on only one input partitions, and wide transformation output partition is dependent on multiple input partitions. uh, Narrow transformations are filter select with column map for transform each row union sample, and wide transformations are like it cause shuffle data move across the network, create stage boundary in DAG. Examples: group by join, listing repartition, order by, reduce by key. When analyze intuitives, when analyzing slow job in Spark UI at FV, I always check how many stages existed at V and which shuffle operation were the bottleneck. Reducing the white transformation like replacing group by uh, duplicate with deduplicates where possible. Help reduce stage count. What is shuffle and why it is expensive? Shuffle is processing the reprocessing of redistributing data across the partition or executors so that related data is grouped together. It involves disk write, network transfer, and serialization, making it most expensive operation in the Spark. Why it is expensive? Because of this input output write, network transfer, serialization and deserialization, where synchronization. How to reduce that? You can use broadcast to eliminate the join shuffle. Also, you can tune shuffle partition. Like you can change the shuffle partition to 100, like that. Default is 200. It is based on the data size. In every pipeline, shuffle was biggest performance bottleneck. I reduced it by 1 using broadcast join for small table lookup. Second is pre-partitioning data on the join key before a multi-step pipelines using equi and dynamic collage shuffle partition. Then what is lazy evolution? Lazy evolution means Spark does not execute any transformation before you call it. It just build execution plan, means that execution only happen when you call actions like count, show, and write. Lazy evolution is lazy evolution. Why Spark is powerful for pipeline changing? In my S3 iceberg pipeline, I had changed 6 to 8 transformation before write action, and Spark optimized the whole thing as a one plan, introducing predicted push down into S3 file metadata. What are job, stage, and task? One line answer is action create job. Job is split into the stages at shuffle boundaries, and each shuffle contains task. One task per partition. Hierarchy application job one action that like count, write, show. Then before after job stages split at each shuffle boundaries, then task per one per partition. Job create every time you call the action. One Spark application can have many jobs. Job is divided into stages at every white transformation. All operations within stage are narrow, and stage executed sequentially. Next stage wait for shuffle to complete. Task, it is the smallest unit of work in Spark. One task is equal to one partition processed by one executed core. If the stage has 200 partition, 200 tasks run in parallel. One task is equal to one partition. 200 tasks means 200 partition in parallel. Each task run the same code but on different data. You will get the partition on get df.read.get partition in bracket complete. Okay. I use Spark UI heavily for optimization. When I saw one stage taking 80% of time, I had a grill into the task. If one task was 10x longer, that pointed to data skew. That's when I applied salting and equi skew join optimization. What is broadcast join and when should you use it? Broadcast join send copy of small table to the every executor so join can handle locally, eliminate the need to shuffle the large table across the network. मीन्स वो क्या करता है, स्मॉल टेबल की कॉपी एवरी एग्जीक्यूटर को सेंड करता है. सो शफल कैन नॉट शफल एलिमिनेट. नेक्स्ट क्वेश्चन, व्हाट इज डेल्टा लेक एंड एक्सप्लेन एसिड in Delta Lake. Delta Lake is open source storage layer on the top of the Parquet that adds acidic transactions, version control, means time travel, schema enforcement, and scalable metadata to Delta Lake. What is the problem solved? Like no, without Delta Lake had problems like no transactions, no schema enforcement, means wrong data got in, no versioning cannot roll back mistakes, a small file problem, many small file packets, concurrent write conflict, like that. So how we can resolve that? Like using transition log. Acidic means atomicity, consistency, isolation, durability. Atomicity means all or nothing. Partial write does not exist. How achieve it? Transition log commit write only if write successful. Then consistency, data always match the schema rules. Schema enforcement, reject invalid write. Isolation, concurrent read or write do not interface, means optimistic concurrency control plus subset isolation. Durability, commit data survivor crashes, means transition log on the cloud storage is durable. In my project we had Apache Iceberg, not Delta Lake, but Iceberg has same acidic guarantees through its own metadata layer. Why, when my multi-thread API ingestion route concurrently from Viva and Revex, Iceberg isolation ensure readers never saw partial writes. What is Z ordering and when should you apply it? Z ordering is the data collocation technique that physically sorts data in files so that row with similar value on shared order columns are stored together, enabling Spark to skip entire file when filtering on those columns. When to apply zero ordering, like column used frequently in where join and group by high quality columns like patient ID, order ID, transaction ID. Multi-columns that are often filtered together. Bad conditions like where you have to know use of zero ordering, like column already used for partitioning. Low quality columns like gender, setters, like that, use partitioning instead. Rarely query columns. Code is like optimize table name or zero order by in bracket column names like partition ID comma load date, like that. Partitioning versus zero ordering. partitioning based for low quality columns and for zero ordering based for high quality columns. Partitioning creates separate folders per values. Zero ordering creates co-located data within files. Skipping partition skipping folder level. Zero ordering skipping file level within the partition. In my project iceberg table, I applied sorting zero ordering on patient ID and load ID, the two common filters columns in downstream queries. This enables significant file skipping and improving query performance. What is optimized in Delta? Optimize compact small Parquet files into fewer large files. Okay, optimize compact small files Parquet into larger one, solving a small file problem that degrade read performance. Detailed explanation: small file problem, like we have many for. In my project pipeline, hourly API ingestion creates small file problems. I schedule the nightly optimized job to compact them. This morning analytics query 3x faster. Then next, what is vacuum in Delta and what does retention threshold mean? Retention threshold means vacuum physically create old data files that are no longer referenced by any version of Delta table, freely up to storage. Freely up to storage means basically vacuum physically delete the old data files which are not longer referred by the transaction logs or referred by the delta lake. The retention threshold controls how far back in time you still want to be able to time travel. The retention threshold control how far back in time you still want to able to time travel. Why vacuum is needed? Delta never deleted old Parquet file automatically without vacuum. What vacuum does? Scan the delta log for file no longer referred by any valid version. Delete those old Parquet files from storage. Cannot be undone. Delete files are no longer gone permanently. Syntax is vacuum table name. It is by default is 7 days. Then if you want to optimize that, syntax is vacuum table name retain to 720 hours means 730 days. Difference between vacuum and optimize. Purpose vacuum of like compact small files and optimize purpose is compact small files, fewer large files. Vacuum is delete unreferenced old files. Optimize delete files no. Optimize delete older files yes. Optimize affect time travel no. Vacuum affect time travel. Optimize run frequency daily or weekly. Vacuum is frequency weekly or monthly. In my project compliance requirement, I was careful with vacuum. Pharma data may need 30 days audit trials. We set retention 720 hours to keep 30 days history before vacuuming. Schema enforcement versus schema evaluation in Delta. Schema enforcement reject write that does not match table schema on by default. Schema evaluation, it automatically update the table schema when no new column appear on the like opt on with merge schema is equal to true. In my pipeline, Wi-Fi API auxiliary added new field. Bronze layer adapt via schema merge, but silver layer that strictly enforcement. If new column appear, the new job would fail and alert me to review the change before letting it propagate downstream. Next, what is checkpoint in Spark? Checkpointing save delta. Checkpointing save data frame or RDD to reliable distributed storage. in HDFS or S3, breaking the DAG lineage chain, preventing recomputation failure and enabling fault tolerance streaming. Checkpointing versus cache versus persist. Cache storage storage is memory. Persist storage memory per disk. Checkpoint storage is like reliable storage S3 or HDFS. Cache lineage broken, no. Persist, no. Checkpoint lineage broken, yes. Cache or persist, there is no service restart. In checkpoint service, yes. Use case cache reuse the same job. Persist large data frames, and checkpoint used for long lineage or streaming. Explain caching versus checkpoint versus persistence. Cache stored in memory, reuse the same data job fast. Persist cache with storage level options like memory plus disk, and checkpoint is equal to save to reliable storage and break lineage for fault tolerance and streaming. In my project, I cache the temporary lookup data frame that was joined with three different source data frame in sample pipeline in same pipeline. Without cache, Spark would reread and reprocess it 5 times. With cache, it was read once and reused. And after cache, we have to unpersist the cache data frame. What does adaptive query do? Adaptive query execution means AQE re-optimize query plan at runtime based on actual data statistics located during execution. Fixing problem that the static planner could not predict, like data skew, incorrect partition count, and sub-optimal join strategy. There are key features, three key features: dynamic coalescing of shuffle partition. Default is 200 shuffle partition. Reality after filter only 5 partition have used. So without AQE 200 tasks, 185 nearly empty, waste of resources. With AQE merges 185 tiny partition to run 5 partition, that is. Then secondly, dynamic switch to protocol join. Plan said like short merge join, because table start like state say large. Reality after where filter right side has only 500 rows. Without a full short merge join with shuffle it is slow. With a small detect small result, switch to broadcast style join, and performance is fast. Then third is skew join optimization. Partition 1, partition 2, partition 3. Partition 1 having 100 rows, partition 2 having 100 rows, partition 3 having 5 million rows. Data takes 10 million skew. Without a queue, entire job wait for and too slow. A queue split partition 3 into smaller sub partitions. How to enable AQE, like spark.sql.adaptive enable true. Then how to enable coalesce, like spark.sql.adaptive.coalesce partition.enable true. Then coalesce partition.mean partition size is 64 MB. Then switch to broadcast join for like adaptive spark.sql.adaptive.local shuffle reader.enable is true. Then AQE to join optimization was key for the pipelines, because some US territory has 10x more patient records than others. Without AQE, those tasks were struggling. Enable AQE skew join automatically split oversized partition and borrow execution time down efficiently. What is cluster mode versus client mode? In cluster mode, the driver run on the machine that submitted the job, means your laptop or edge node. In cluster node, the driver runs inside the cluster on the worker node. More fault tolerance for production. In my project, I use Databricks notebooks, means client mode, for development and debugging, and production job triggered by ADF run as Databricks job in cluster mode. The driver was managed by Databricks and did not depend on any user session staying active. What does Spark handle fault internally? How does Spark handle fault internally? Spark handle fault through task retry, rerun failed tasks on other executor, lineage based recovery, recompute lost partitions, and checkpointing for streaming fault tolerance. In my project, I did root cause analysis on connectivity failure. When Oracle JDBC connection timeout mid task, Spark retry the task, but its connection issue was persistent. All four trials failed. My fix was to add connection retry logic in JDBC option and increase the connection timeout settings. Why dynamic partition pruning? What is dynamic partition pruning? Dynamic partition pruning uses the result of filtering one table in join to skip partition in the another table. Evaluate at runtime, not at partition time. On my 20 plus TB iceberg table at FV, dynamic partition pruning was crucial. Table where partition by load date table where partition by load date, queries the joined with a filterized dimension table would previously scan all partition. With ADPP enable, only relevant data partition were opened, reducing scan size from 20 GB to 2 TB to 20 TB to 2 TB for typical data range filter queries. That's about this Spark and Databricks core concept. So there are some practical examples. So we will do manually. Bye.